Alright, so in this video we are gonna go over the final part of the regression review, um, which is about the concepts of the panel data model and the binary dependent variable model. So for the panel data model, we have this data set called CIGAR, where we observe individual state by state, except we have multiple rows of the same state, and that's because we're observing this state over time. And that's how a panel data is unique compared to like a standard data set or like a time series model. And so what I did here is I made like a standard pooled regression with the argument of model equals pooling. This is what I call the P model, the pooled model. I made two fixed effect models of argument of model equals within. But the effects of the fixed effect model are specifically different because one accounts for these differences of the same individual. So within each state, do we know if there are differences within the individual, or sorry, are there differences across individuals? So differences state by state. Are there differences of like price and population year, state by state? And or are there differences within time? So within the same individuals, by passing year, are there differences, in price or sales or population or whatnot? And if we have these differences, but they're not by individual or time, then we'll call it the random effect model, which we also learned about. All right. So first, we're gonna test for heterogeneity with the pooled effect model, which is rejected because intuitively we know that either by time or individual, and in this case we tested by individual, but I guess just for individuals, we know that these population and price are going to be different across states. So the price of a product, an average price of a product in California will probably be more expensive than the average price in Nebraska, for example. So intuitively we know that, so statistically we also end up rejecting the pooled regression model. And so we know from there to use a fixed effect or the random effect. Now, when we use the fixed effect model, we have to account for either the individual differences or the time differences. And so what I did was make a summary for both. And what really just matters in this case is the p-value. So if our p-value for either one is rejected, if the p-value for both of them is rejected, then we'll conclude that we use the two-way effect model. And so that's what happens here is we reject both, and so we conclude that there are both individual and time differences within the data set. So across states, across each different state, we have different characteristics, and across time within each state, we also have different trending population and sales and CPI values. All right. So now that those are rejected and we conclude that a fixed effect model is necessary, we can confirm that by making this fixed effect model that includes two ways, both the individual and time effect. And then we can also test for endogeneity between the fixed effect and the random effect model using the Hausman test. And unsurprisingly, this test is rejected. The null hypothesis is rejected, which means there is endogeneity, and so a fixed effect model we conclude is more necessary than the random effect model, because these differences are not random and they are consistent across individual and time. if the random effect model, if we don't reject the null and we conclude that there is a random effect model, then we conclude that these differences across individuals and time are random and not necessarily have like a pattern across them. All right, so that's it for the panel data model. Moving on to the binary dependent model, we have like another data set here where we have these different kind of characteristics that determine the labor participation, chance of someone participating in the labor force. And so just like we did for driveway of the first data set, we have to convert these values into 1 or 0, yes being 1 and no into 0. And so that's what I did here. And so starting off with the linear probability model, I regressed both education and income to participation because intuitively I just use these two as the main predictors for participation. And so when I summarized it, we get these kind of coefficients. Now off the bat, remember that these coefficients are based on the probability. So education doesn't seem very impactful onto the labor participation percentage, labor force participation percentage, but income, we can interpret this as if 1 unit of income increases, we don't know what that 1 unit is, but if 1 unit of income increases, then there will be an average decrease of the labor participation, someone participating in the labor force by 18.86%, a decrease, which is pretty significant. We don't know what the unit of income is, but it seems pretty significant. The AIC I also calculated, which is 1239. That will be useful for like the context compared to the probit and the logit model that I'm gonna do just about now. But before that, remember that for the LPM we have to correct for heteroscedasticity, not heteroscedasticity. We have to test for like heteroscedasticity. So that's what we did. That's what I did here. So now this standard errors are correct for use in case we want to do like hypothesis testing. All right. So moving on to the probit model, we have this family which is probably a variant of the GLM function, but we have the link equals probit, which implies that it's a probit model. And notice that these coefficients are actually much different from the coefficient from the probability model, which makes sense because the probit model uses a different algorithm. And so what we can interpret this as is if there's a 1 unit increase in the income, then that will result in a negative 0.5 decrease in the labor participation force. Not necessarily percentage because that would be way too big. But we can interpret that as like a times decrease for the probit model. And notice how the AIC is automatically calculated here. So we can kind of compare that to the linear probability model and notice that the AIC for the probit model is smaller. So if we're deciding which model to use, then we're going to decide on the probit model, even though the LPM isn't necessarily useless. It's still good to compare, but lastly, moving on to the logit model, we have this similar argument to the probit model, except we switch into link equals logit. And so we get the similar AIC value, but these coefficients again are different because, the education coefficient is mostly the same. It's very close to 0, but the income coefficient is different. This time it's negative 0.8. Now the overall effect of the determinant of how income affects the participation rate should be around similar, but because we have these models use different algorithms and interpretation formulations, we have to interpret in a different way. So a 1 unit increase in income means there's a 0.8 decrease in the log odds of success. So much smaller than 0.8, we have to log this output, but that's basically what it's saying. Now notice that the AIC for the probit and logit are very similar, so we don't necessarily know which model we prefer. I think in this case both is appropriate, but just interpreting the effect of income onto the labor force participation percentage, we can generally see that as our income increases, the chance of someone participating in the labor force will decrease. And that makes sense because as someone's salary increases, they're not, or I guess in another way, if someone's not making a lot of money or salary, then there's a good chance that they'll find another job or quit working, or maybe they're not satisfied with it, all those stuff. And so that's why people with lower income are more likely to participate in the labor force. And so the education, again, we kind of concluded that it's not very significant, but it is slightly negative as well, so which is kind of confusing, but usually we would suspect that people with higher education would less likely participate in the labor force. But I guess in a way, if we survey people that just graduated or just finished their education and are looking for a job, then I guess this kind of coefficient makes sense because it can kind of be a balance of both. But yeah, that is basically it for the analysis of these different models of binary. We've also done some of these analysis for the fixed effect, random effect, pooled model, and we've covered the time series models, and then just the standard regression with linear and multiple regression, and finding the ideal model using BIC and reset tests and interaction variables. So that is it for my our review of this singular and multivariate regression. In the next series of videos, I'm going to move on to forecasting, which is kind of similar to what we did in these videos, in my regression videos, but we're using those regression analysis that we've done to predict future values, to forecast a confidence of values and interval values, or just predictions, specific values. But we're looking more into the future now instead of going to these analysis of the past. But we're using these past analysis of regression coefficients to predict the future. So that's what I'm going to do in the next set of videos. But I am finished with these singular and multiple regression series.